afternoon, ladies and gentlemen. I'm John, and I'm here today to talk to you about concrete everything. Well, not really in one video. This is only going to be like 3 minutes, so exaggerated, just a skosh. A modicum, if you will. But we are answering, it is Q&A Wednesday, ding! So we have a question from Swedish Death Llama. You know, I love that name. I don't know why Swedish Death Llama is such an awesome name, but it just rolls off the tongue, right? I mean, it's just a great name.
Tickles my fancy.
Ding! Very cool video on Math Monday, colloidal silica particle size calculations. Next math question. How do you calculate the ideal gradation of silica particle sizes for optimal particle packing in UHPC? You know, yes, Swedish Death Llama, that is a great question. And I wrote a paper that doesn't really go into the particle size distribution and the gradation envelope of all the materials that you're using in your concrete, mortar, or grout composite. And there are a lot of different programs out there. There's LISA, there's a tarantula curve, and you know, all these private industry has their own. I mean, basically what you're doing is a paste to aggregate ratio, aggregate to paste ratio, or you can look at a gradation envelope using particle size distribution and known information out there with UHPC designs. So you're basically just going to take the dry weight of your nanosilica size particle in solution that you're adding and the particle size distribution of that and fit it into your, I mean, but you know, quite honestly, you're not adding a lot. You're adding within the standard deviation of some of the other materials. So your gradation envelope, I don't know, you might, if you focus just on your binder matrix as opposed to your entire concrete composite, I think you'll do a lot better. And you can relate it to, I guess, using, what's that European test? Oh my gosh. The Rigdon void analysis. And that'll give you, help you get porosity index, packing density. But you know, the fact remains is, with these nanoparticles, it's not just about the gradation envelope, it's also about the chemistry of the concrete. So whether or not you get the packing right and you know your gradation right, you'll still have to go through the histrionics, the labor, the trial and error, I guess, of the different types of colloidal silica, whether it's the modification, the pH that they come in, and you might want to go for a narrow distribution within a larger distribution if that's what you started with. So how to come up with the right one, it really is trial and error. So thanks for joining, thanks for the question. Let us know if you got any other concrete questions, concrete concerns. Don't forget to like and subscribe. Ding that bell for notifications. Go, go, go!